right, so lesson 6.3, we're going to separate into 4 different lessons talking about the properties of radicals. All right, so let's say that I have a radical of 2 things times each other. I can separate that into the radical of the first thing times the radical of the second thing, and vice versa, right? If I have 2 radicals being multiplied together, then I can squish them together into 1 radical, okay? You just want to make sure that those 2 numbers are bigger than 0. So a simplified radical means that you can't simplify it any further. So the number underneath a square root needs to be a prime number or the number that's a product of 2 prime numbers. So for instance, let's say I had 8 under a square root. 8 is not a prime number. By the way, give me some prime numbers, like 2, that's the only even prime number. 3, 4 is not a prime number because it divides by 2, right? 5, 6 is not prime, it divides by 2 and 3, 7, so on and so forth, right? Those are prime numbers. So 8 is not a prime number, and when I say the product of 2 prime numbers, product means multiply, right? So 2 prime numbers, let's say like 2 and 3, that multiplies to make 6. That's an okay number to have left under a square root, because if I try to split 6 up, all I get is 2 and 3, and neither of those are a perfect square, right? I can't square root them and come up with an integer, or a whole number. So the first number in your should be a perfect square. The second number should be a prime number, or a number that's the product of 2 prime numbers. Now, when you get to algebra 2, if you can split those and realize that 8 is the same thing as 4 times 2, and 4 is a perfect square, right? The square root of 4 is 2, and then the prime number gets left underneath the root because I can't simplify it anymore. That's my answer. But since we're not super good at these, and I want you to do these the same as you do cube roots, we're going to do them with factor trees. All right, so I'm taking the square root of 108. Now, the first thing I always do is I check to see if the number is a perfect square. So if I take this number and I square root it, so second, and then you would press this little x squared button because that's where the square root is, of 108. Okay. Notice that it actually tells me what it is. All right. Your calculator will actually do these, the small ones. The like TA84s that they use in other classes, they just give you the decimal. Okay, this is not a perfect square, right? I ended up with a root in my answer. But I do also realize that this is going to be my answer in the end, right? I should know what that is. Okay? And also, if I get a decimal for that, then it wasn't a perfect square. So what we're going to do is we're going to do a factor tree for 108. So 108, that is even. If it's even, I always just divide it by 2. So 108 would be 2 times 54, right? And then we circle the prime numbers, right? 2's a prime number. And then 54, that's even, so it'll divide by 2. 2 and 27. So 2 is a prime number. And 27 does not divide by 2, but it divides by 3. So 3 times 9, 3 is a prime number. And 9 is 3 times 3, both of which are prime numbers. So once I've got all the prime numbers, what I'm going to do is I'm going to write them as prime factorization. So I've got 2 of the 2's, right? So that would be 2 to the second power. This power represents how many I have. And then I also have 3's, and I have how many of those? 3 of them. So I want you to think about this. I'm going to end up splitting this into different roots, okay? And I know that under a root, I would take the power and I would be dividing it by the root number, right? So if I were to square root this right now, will this 2 divide evenly by the root number of 2? Yes. 2 divided by 2 is 1. So therefore, this is a perfect square. But if I were to square root this one, would 3 divide by 2? No. So I have to split this one up. So I know I'm going to use the 2 squared, but I'm going to have to split up my 3 into 2 separate roots. So think about this number right here. What is the biggest number that's smaller than 2, or smaller than 3, that will divide by 2? 2. So I'm going to put 2 of my 3's under this one because that makes a perfect square, right? And then, how many are left? Just one of them. So now I'm going to work this out. What is the square root of 2 squared? That would just be 2 to the first power, correct? And that's because I'm taking 2 and dividing it by the 2 that's out here, right? So what would be the square root of 3 squared? Just 3 to the first, right? And then, when your power is smaller than your root number, then you can't do anything with that. So the 3 will stay underneath the root. Now I have 2 things on the outside I need to multiply. 2 times 3 is 6. And then you have your square root of 3 at the back. And that's what the calculator told us we were going to get in the end, correct? All right. So let's do the 147. Let's do that. It's not a perfect square, okay? So if you were looking at that, if you took the square root, it's not a perfect square. And if you're not sure what it divides by, well, I know it doesn't divide by 2 because it's not an even number, but it does divide by 3. It's 3 times 49, and 3 is a prime number. And then we can split 49 into 7 times 7, which are also prime. So if I write down what I have 2 of these 7s. And then how many 3's do I have? Just 1. So I'm going to look at the exponents here. Will the 2 divide by my root of 2? Yes. So this is my perfect square. That's the one that's going to go in the front. I always put that one in the front. And then this one has a power of 1. That is smaller than 2, correct? So therefore, it's going to just go underneath here. I don't split it or anything like that. The only time I need to split it if it's bigger than my root number, right? So I've got the square root of 7 squared is 7, because the square and the square root end up canceling, right? Because 2 divided by 2 is just 1. And then you have your square root of 3, and you're done. On number 3, we've got 24. That's not a perfect square. Always check to see if it's a perfect square. So let's split 24 up. We've got 2 times 12. So 2 is a prime number. And then 12 we can split into 2 times 6. 2 is a prime number. And then 6 is 2 times 3, both of which are prime numbers. So if I wrote this out, I have 2, and I have 3 of those, and then I only have 1, 3. So if I look at my exponent, that's bigger than 2, correct? Will it divide by 2? No, 3 does not divide by 2. So I know I'm going to have to separate my 2 into 2 things. So let's think about that. What would be the biggest number smaller than 3 that will divide by the 2? 2. So I've got 2 2's. That's going to be a perfect square. And then how many 2's do I have left over? I just have one of those 2's left. So I took care of this. Now 3 has a power of 1, and that's smaller than 2, right? So I will not split my 3 up. So what is the square root of 2 squared? It's just 2. And then neither of these can be reduced, correct? So I just multiply them together. 2 times 3 gives me 6 underneath my root. and I could plug that in the calculator. It's going to tell me that you should have 2 square roots of 6. All right, number 4, the only difference is I have a negative out front. So what we're going to do is we're going to simplify the square root of 80, and then we'll put a negative in the front of it. We just don't want to forget that it's there. So let's do our factor tree for 80. We've got 2 times 40. 2 is prime. 40 is 2 times 20. 2 is prime. 20 is 2 times 10. 2 is prime. And 10 is 2 times 5, which are both prime. So I have 1, 2, 3, 4 of the 2's, and then I have a 5. So first, I'm going to look at this and say, okay, does 4 divide by 2? Yes. So I'm going to keep that one. That's a perfect square, so I don't need to do anything with it. Make sure you keep your negative out front. 5 has a power of 1. That's smaller than 2, correct? So that one just stays under my root like that. So I have to simplify this first one. Don't forget to keep bringing down your negative. Now remember, you're taking the exponent and dividing it by the root, right, to put it in exponential form. So this would be 2 to the 4 divided by 2 gives you 2. And then remember the 5, we can't do anything with that. And then you just need to finish that off. What is 2 squared? 4. So we have negative 4 square roots of 5. And again, you could check that one in your calculator just to make sure that you were correct. All right, so let's try 75. Okay, it ends in 5, so I know it divides by 5. So 5 and 25, right? No, not 5 and 25. 5 and, I can't multiply today. 15. 5 is prime, right? And then 15 is 5 times 3. Those are both prime. So I have 2 of the 5s, and then I have 1 of the 3s. So does the 2 divide by 2? Yes. So I know that I have the square root of 5 squared. That's my perfect square. And then 3 has a power of 1. That's smaller than 2. So I'm not going to do anything with that. I'm just going to leave it under the root. So what is the square root of 5 squared? 5. And then I have my square root of 3. Notice all these numbers that stay under the root are prime numbers or numbers that are the product of 2 prime numbers. Okay. All right, 96, not a perfect square. So we're going to go ahead and do our factor tree. So it ends in a 6. That's even, so we can divide by 2. So 96 divided by 2 is 48. 2 is prime. 48, that's even, so it divides by 2. 2 and 24. 2 is prime. 24 divides by 2. 2 and 12. 2 is prime. And 12 divides by 2. 2 and 6. 2 is prime. And 6 divides by 2. 2 and 3, both are prime. So we have 1, 2, 3, 4, 5 of the 2's. And then we have a 3. So look at your exponent. That's bigger than 2, right? Does 5 divide by 2? No. So now I would say to myself, what's the biggest number that's smaller than 5 that will divide by 2? That would be 4. So I'm going to use 4 of those, which means how many are left over? Just 1 of them, correct? All right, your 3 has a power of 1, and that's smaller than 2, so it just stays under the root. Then I have to take this perfect square and square root it. So the square root of 2 to the 4th would be 2 to the 2nd. And then these are both of the numbers I couldn't reduce anymore, so I just multiply them together. 2 times 3 is 6, and that stays under my root. And then go ahead and take and square your 2. 2 squared is 4, so I get 4 square roots of 6. So now we're going to add in some variables, all right? And you're going to do these like it's two separate problems. So focus on your number, and then you're going to focus on your variables. So split them up, and then we can put them back together. So 9, that's a perfect square, right? Okay, so I don't need to split the 9 up into anything at all, and I don't need to do a factor tree because it's a perfect square. So I'm going to leave that alone for now. I like to do all of my perfect squares at the same time. All right, and then 3. 3 is bigger than 2, right? But 3 doesn't divide by 2, which means you're going to have to split your variable into 2. So what is the biggest number smaller than 3 that will divide by the 2? A 2. And that leaves how many x's left over? Just 1. So now you've got a perfect square right here, and you have a perfect square right here. So let's do those first. The square root of 9 is 3, and the square root of x squared is x, and then you have your square root of x at the back. So your calculator will not do these, okay? They'll do the number, but not the variables. Don't try to put in x's in there. Okay, so let's do the number and the variable separate. All right, 25. Do we need to do a factor tree for that? No, because 25 is a perfect square. By the way, I am going to point this out, though. Let's say that you did do a factor tree. You would get 5 and 5. That's it, right? And that's 5 squared, which is a perfect square, right? Okay, what about your x to the 5th? Is that a perfect square? No, 5 is bigger than 2, so what is the biggest number smaller than 5 that will divide by the 2? A 4. So I'm going to keep my 25 by itself because I know I'm going to square root that. And then I'm going to split my x to the 5th into x to the 4th, and that leaves how many x's left over? Just 1, right? And remember, we always want to make sure that that power left over underneath is smaller than the 2. So the square root of 25 is 5, and the square root of x to the 4th is x to the 2nd. And then you've got your square root of x. All right, so again, we're going to split this up into the coefficient there and then the variable at the back. So since 75 is not a perfect square, we're going to have to split it up. So I know 75, that divides by 5. We did this one a while ago, right? So 5 and 15, and 5's prime. And then 15 is 5 times 3. 5 is prime, and 3 is prime. So if I wrote this out, it would be 5 to the 2nd and just a 3 to the 1st, correct? So this 2, that will divide by my root of 2, right? So this is a perfect square. I don't need to split that up. But the 3 has a power that is smaller than 2. So that's the one that's going to stay underneath my root. So I've done my 75. Now we do the variable. So 5 will not divide by 2, correct? So I'm going to take and split it up. What is the biggest number that's smaller than 5 that will divide by the 2? That would be n to the 4th, and that leaves an n left over. So before you start square rooting things, identify the ones that are your perfect squares, right? That would be the 5 squared and the n to the 4th. And do those first. So the square root of 5 squared is 5, and the square root of n to the fourth is n to the second. And then underneath the root, and if you like, you can cross them out, like you've already done them. Underneath the root, you have a 3 and an n. So the square root of 3n. And remember, you should not have any powers that are your root or bigger. All right, so let's split this up into 162 and x to the fourth. So we need to do a factor tree for the 162. So 162 will divide by 2. It's 2 and 81. 81 will not divide by 2, but it will divide by 3. So 3 and 27. 3 is prime. 27 is 3 times 9. 3 is prime, and 9 is 3 times 3. All right, so I always list the ones that have the most numbers first. So 3 to the fourth, and then you have a 2 to the first. So first, check out, will 4 divide by your root of 2? Yes. So I'm not going to do anything with my 3 to the fourth. And then 2 to the first, that's smaller than 2, right? So I will keep that 2 underneath. All right, will the 4 of your x, will that exponent divide by 2? Yes, so I don't need to split my variable into anything because it's already a perfect square. So out of those 3, you have 2 perfect squares. This first one, and then the one at the back. So I'm going to do those 2 first. The square root of 3 to the fourth would be 3 to the second. And the square root of x to the fourth would be x to the second. So I took care of my perfect squares, and then all that's left is the square root of 2. And then you're going to go ahead and make sure you square that. 3 squared is 9x squared, square roots of 2. Make sure you always simplify that number in the end. So let's do the square root of 180 and the square root of x to the ninth. And let me keep reminding you, always check to see if the number there is a perfect square. 180 is not a perfect square. So we'll do a factor tree for 180. So 180, that's even, and it'll divide by 2. So 2 times 90. 2 is prime. And 90, that's even. It'll divide by 2. So 2 and 45. And then 45 will not divide by 2, but it will divide by 5. So it's 5 and 9. And then 9 is 3 and 3. So this is the first problem where we have had 3 different numbers, right? So we have 2 2s. We have 2 of the 3s. And then we have a 5 to the first. So look at each one of them individually. Is 2 to the second power a perfect square? Yes. So I don't need to do any splitting with my 2. Is 3 squared a perfect square? Yes. So I don't need to do any splitting with my 3's. Is 5 to the first a perfect square? No. And that number is smaller than 2, right? So I know that that's going to be one of my numbers left underneath my root. All right, then we have our x to the ninth. Will 9 divide by 2? No. So I need to split that up. What is the biggest number smaller than 9 that will divide by 2? 8. So I would do x to the 8th, which leaves an x left over. So I have 5 separate things here. Let's identify the ones that are perfect squares. So anything with a power of 2. So that, or an even power. 3 squared, that's a perfect square. And then the x to the 8th. So we will do those 3 first. what is the square root of 2 squared? 2. All right. Then we have the square root of 3 squared. That is 3. And then if you want to mark them off as you go. And then the square root of x to the 8th is x to the 4th, because I just take the 8 and divide that by 2. And then underneath your root, you have 5 and x. So multiply those together, and that's what's left underneath. And then you need to go ahead and simplify what you have out front here. So 2 times 3 gives you 6, x to the 4th times the square root of 5x. If you really just break it down to each little piece instead of trying to do it all at once, it really makes it a lot easier. So 36, we've got the square root of 36. That's a perfect square, right? So we don't need a factor tree. And the square root of x squared, that's also a perfect square, right? So the square root of 36 is 6, and the square root of x squared is x. And then we're finished with that one. All right, so we have the quotient property of square roots that says if I'm taking the square root of something divided by something else, I can do the square root of the top and also divide by that by the square root of the bottom. Sometimes, I'm just going to point this out, sometimes they might give you something like this, where they're already separated. Is 18 a perfect square? 9's a perfect square. This is probably, let's do 2. All right. Neither one of those are perfect squares, and I would actually do a lot of work to actually simplify this, because you don't leave roots in the bottom. It's just kind of frowned upon. But I could put them back together, right? And do 18 divided by 2 under one big root, which gives you the square root of 9, which is 3, right? So if they're already separated, but it would be easier to put them back together, then put them back together. Okay? All right, so these are separated, and 15 and 64, those do not divide evenly, right? I always check that. So let's square root the top, and then let's square root the bottom. Now you still always need to fully simplify, okay? So 15 is not a perfect square, right? And if I did a factor tree for 15, it would just be 5 and 3. So I only have one of this, and I only have one of this. That's the product of two prime numbers, right? I can't simplify or split that up, so that will stay. But I do know that 64 is a perfect square. So keep the square root of 15 on top. The square root of 64 is 8. There's no simplifying to be done, so I'm finished. So when I do 14, what do you know about 81? 81 is a perfect square. And what do you know about x squared? That's also a perfect square. So if I square root the top, I get 9. And if I square root the bottom, I get x. All right, so we'll do the same thing here. 11 over 36, not really helpful, so I'm going to square root the top, and I'm going to square root the bottom. So 11, that's a prime number, right? So we can't do any simplifying there. But I do know the square root of 36 is 6. All right, so let's add in some variables here. So I'm going to square root top and bottom because I can't simplify that fraction underneath. So the square root of 144 over the square root of n squared. So 144 is a perfect square. So the square root of 144 is 12. And then the square root of n squared is n. And then I'm finished with number 16. So on 17, we'll do the same thing. You can't simplify this fraction here. And sometimes even if you can, if they're both perfect squares, you wouldn't want to, right? Because you're going to square root them. So the square root of 36 on top, the square root of z squared on the bottom. The square root of 36 is 6, and the square root of z squared is z. Now 18 is just a little bit different because you have two things on top, right? Two terms in your product. So you need to actually make sure that you square root the 4 and you square root the x squared. And if you need to simplify those, then you can. And then you have the square root of 64 on the bottom. Now, I do want to point this out. This is one of those where I was saying that if you can reduce, you may not want to. 4 over 64, that will reduce, right? But when I reduce them, okay, 64 divided by 4, well, in this case it works out. That makes 16, which is still a perfect square. So on this one you could reduce. But if you reduce and then it didn't make it a perfect square anymore and you're going to end up square rooting it, then you wouldn't want to do that. So square root of 4 is 2. The square root of x squared is x. And the square root of 64 is 8. Then I need to make sure that I reduce right here. So 2 will go into 8 4 times. So I have x on the top, and then I have a 4 on the bottom.